Good morning. Today we are going to start section T3. Actually, T4. We're on T4. And we're going to look at what we call trigonometry. Okay. Trigonometry is used with triangles. And today what we're going to specifically look at is right triangles. Okay. So we're going to look at right triangles. Okay. Now, in trigonometry, we focus on two main things. We focus on the sides of a triangle, and we focus on angles. Okay. So, before we get into the main parts, let's look at a right triangle. Okay. Oops. Okay, so we have a right triangle. Right triangle has a right angle. Okay. And we're going to focus on this angle right here. This is going to be called angle theta. Okay. Now, from this angle, there's three sides we're going to look at. The longest side is called the hypotenuse. The side next to that angle is called the adjacent side. And the side across from the angle is called the opposite side. Okay, so let's look at that again. There's the opposite side. There's the hypotenuse. And there's the adjacent side. Okay. Okay, so hypotenuse is across from the 90-degree angle. It's the longest side. The opposite side is opposite of your angle. And the adjacent side goes next to your angle. Okay? So, hypotenuse is the longest side. Adjacent is next to the angle. And opposite is opposite of the angle. Okay. So we have an angle, theta. Sorry. Okay. We have a hypotenuse, an adjacent side, and an opposite side. Okay. Now, trigonometry. Trigonometry is used for what we're looking at today. Let's say we have angle theta. And we say we're standing 10 feet away from a tree. And we're looking up at an angle of 40 degrees. We can actually figure out the height of the tree if we're looking at the top of the tree based on that angle. Okay, that might have been confusing. I'll actually do an example. Okay, but before we get into that example, first thing we need to know: hypotenuse, adjacent, opposite, and our given angle. Okay, now I'm going to be introducing a lot of things today. If you get stuck, don't worry, rewatch the video. I'll post more videos on this. Just we're going to take our time with this. Okay, so we have a right triangle. Now, in trigonometry, there's three main functions. We have what's called sine, cosine, and tangent. Okay. Abbreviated, we call this sine of theta, cosine of theta, and tangent of theta. Okay, so if you look at your calculator, you may have seen these letters here. SIN, COS, and TAN. Okay, sine of theta. Okay, these are the rules. Sine of theta is equal to the opposite side divided by the hypotenuse. Cosine is equal to the adjacent over the hypotenuse. And tangent is equal to the opposite over the adjacent. Now, you may have heard of this before, okay? So to help us remember sine is sine of theta is equal to opposite over hypotenuse. Sine opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. Okay, so the way to remember this is SO, CA, TOA. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. Okay, now, this is a lot of new information. Okay, you may be asking yourself, what are we doing? How is this applicable? We're going to get there right now. But the main things, again, to remember: hypotenuse, adjacent side, opposite side, and then we have sine, cosine, and tangent. Sine of theta is opposite over hypotenuse. Cosine of theta is adjacent over hypotenuse. And tangent of theta is opposite over adjacent. Okay. So, let's look at an example. Okay. This is going to be a little bit of an estimate. Okay. But we will use this. Okay, this will be our triangle with an angle of 35 degrees with an adjacent side length of 4.0 and opposite side length of 2.8 and a hypotenuse of 4.9. Okay. Now, if we're going to find if these main functions work, let's see right here. So, sine of 35 degrees is equal to opposite over hypotenuse. Cosine of 35 degrees is equal to adjacent over hypotenuse. And tangent of 35 degrees is equal to opposite over adjacent. What I would like for you to do right now is pause the video, go ahead divide those fractions and simplify to the nearest hundredths. Okay? Go ahead, do that. I'm going to do those simultaneously. Alright. I made a mistake. Sine of 35 degrees. Opposite over hypotenuse. Hypotenuse is not 4.0, 4.9. So, I made a mistake if you're watching this. So, 2.8 divided by 4.9, 0.57. Man, I'm all over the place. Also, just round to the nearest hundredths. Alright, so hopefully you get 0.57, 0.81, 0.70. Okay? Now, let's go to the calculator. When you're using Google Calculator, if you look in the upper left corner, I'm flipping between two things, rad and deg. Rad stands for radians, deg stands for degrees. You want degrees open. Okay? So, first thing, sine of 35 degrees. Let's round to the nearest hundredths, 0.57, which is what we got. Next one, cosine of 35 degrees equals 0.819. Okay, and tangent of 35 degrees, 0.70. So like I said, estimate, this right here isn't perfect, okay? That's why right here it's off a little, okay? But these should match up. Okay, I just try to come with the numbers in my head. So, sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. Okay, these should match up. Okay, they should match up. If you're getting numbers that are different, for instance, when I did sine, and your numbers look like this, that means you're in radians. That means you need to switch to degrees. Okay? So, main thing to take away. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. Okay, so how do we apply this? Okay, how do we use this? Okay, we use it in a lot of different situations. Okay. So let's say I'm going to do a diagram. How should I do this? Okay. Here's a river. Here's a tree. Okay. Here's Mr. T. And here's my friend. Okay. So, the question here is going to be, if I cut down the tree, can my friend use it to cross the river? Okay, now that I think about it, I gotta redraw this picture. The river is gonna butt up right against the tree. And it's gonna go right against the person. Okay, so this tree needs to fall and lay over the river. Okay, so first thing he's gonna do is remember what he knows about trigonometry. Okay, he's gonna have a right triangle. Okay, here's a right triangle. And he knows that this angle right here is going to be 48 degrees. Okay? And he knows that the height of the tree is 20 feet. But he doesn't know how wide the river is. Okay? So, from his view, he has two sides. He has the opposite side, and he has the adjacent side. Okay? So opposite and adjacent comes from here. T stands for tangent. Okay? So he knows that the tangent of 48 degrees is equal to the opposite over the adjacent. Okay. Now, we're solving for x. What is the width of the river? Okay. So, x is on the denominator. How do we get rid of x on the denominator? Multiply x to both sides. X times the tangent of 48 degrees equals 20. Now, to get rid of tangent of 48 degrees that's connected to the x, we divide. So now those cancel out, and we're left with x equals 20 divided by the tangent of 48 degrees. Okay? So, we could plug this in. 20 divided by the tangent of 48 degrees equals 18. Let's round that. 18.01. So, the tree is 20 feet high. If I chop it down and it falls, it's going to be longer than the width of the river. So, is my friend going to be able to cross? Yes. Let's do another one. Okay, I'll do less diagrams to make things easier. Okay, maybe I'll use some diagrams. So, I'm standing away from a wall. Okay, so I'm standing away from a wall. And there's a height that I want to get to. Okay, so there's this little point on the wall. Let's say it's 30 feet up. And I want to get up there, and maybe I need to paint something 30 feet up on this wall. Now, I need to know how tall does my ladder need to be? Okay. That angle theta, let's make this 62 degrees. Okay. That's x. We don't know what the length of the ladder is going to be. So just like the previous question, let's set this up. We have the opposite side of the angle, and we have the hypotenuse. Opposite and hypotenuse, right there, sine. Okay, so sine of 62 degrees is the opposite over the hypotenuse. We just solved a question like this. Okay. How do I get rid of the denominator x? Multiply it to both sides. How do I get rid of sine of 62 degrees? Divide both sides by that. X equals 30 divided by sine of 62 degrees. So, how long does my ladder need to be to reach that point on the wall, 30 feet high up? I do 30 divided by the sine of 62 degrees. And I get 33.98. That's a long ladder. That's a really long ladder. Okay, so this is how trigonometry is used. When you're given a little bit of information and you need to find more, we can use this. Typically, it's for heights or how far away something is. Maybe if you're talking about basketball and trajectory, this isn't the best way to use it, but it could be applied. All right. And let's look at one more. Okay. What's a good example? Oh, okay. So, this is something I did maybe last summer. Okay. I was swimming on the surface of my pool, and I was trying to throw these little like pool toys. They're kind of like darts, and I was trying to hit a target on the bottom of the pool. And let's say my angle was 28 degrees. And I knew the distance I was throwing that dart was about 23 feet. No. Sure. We could do 23 feet. Okay. And I would hit this little target. at some distance away. Okay. But from this, I could actually figure out how deep the pool was, how far down the dart was going. Okay. What was the depth of the pool? So, using this information, I can find the height, how deep the pool is. Okay. So, I have my adjacent side, and I have my hypotenuse. So, what uses adjacent and hypotenuse? Cosine. Cosine of 28 degrees equals adjacent over hypotenuse. Now, this setup is nice. It's a lot quicker. I need to get rid of 23, so I multiply it to both sides. And then I just solve. 23 times the cosine of 28. And I get 20.31. So that's how deep my pool was. Probably not. Pools are usually only like 10 feet deep. But that's how I could find the depth of the pool. So all the questions are going to be set up like this. Let's do this. No, what I'll do is I'll leave the video here. What I'm going to be trying to doing is adding more videos with just examples of how things are done, just so this video isn't too long. You could go back to another video. So I'll give you another video with just how sine, cosine, and tangent are applied. We're going to continue more with trig stuff, but I don't want this video to get too long. Hopefully this is helpful. Okay. Most of the questions, the triangles are going to be drawn out for you. There may be some questions where you have to draw your diagram. Do your best on those. Again, I got a lot of good questions from T1 and T2. Those topics were kind of confusing. I went through things pretty quickly. I should have took my time. Hopefully you saw the review videos. Hopefully those were helpful. But again, continue to ask me questions through Gmail. Ask me questions through Google Classroom. I'm going to post a separate video talking about the Google Meet on Friday. You'll see in that video more, but just a couple things. When we do the Google Meet, I'm going to have us on mute, and I'm going to have it so we don't show our faces just for privacy reasons. And then in the chat section, you'll be able to type in what questions you may have from previous homeworks or anything, and then I'll just go through a bunch of stuff. Okay? So hopefully you find this video helpful.